Morning all. Myself C.H. S.V.Prakash, working as Assistant Professor in the Department of Electrical and Electronics Engineering from Nandi Institute of Engineering and Technology. Today I am here to present a introduction on power system operation and control. First, what is what is power system? An electric power system is a network of electrical components deployed to supply, transfer and use electric power. Supply nothing but supply what we have to supply the power because it's power system. To supply the power we have to generate. From where we have to generate? By using different types of plants. By using different types of plants we can generate the power in megawatts, that is generation. And after that this power should be transferred. And where it to be transferred? It should be transferred to the substations, and from the substations the consumers can utilize this power. So that we can make a statement: an electric power system is a network of electrical components deployed to supply, transfer and use electric power. Now the main components of power system. Already I told that generation, high voltage transmission and distribution system. So here how can we can generate? By using different types of plants. What are the different types of plants? It may be nuclear power plant, thermal power plant, or hydroelectric power plant, or geothermal power plant, or solar power plant, or solar thermal power plant, or diesel power plant, etc. So by using different types of plants we can generate the power. How can they generate? Already you are learned in the your previous semesters, that is power systems 1. And then after transmission. So for transmission also you know that short transmission, long transmission, what are the losses in that. Already we are all learned. This one is also in power systems 2 subject. So you are all know that how it will be generated, how it will be transferred. And then distribution system. So this subject you are going to learn in your final semester, that is electrical distribution system. That is electrical distribution system. So what happens in electrical distribution system? In electrical distribution system you are going to learn that how the distribution system planning, and what is the schematic view of distribution system planning, and what are the factors affecting in distribution system planning, and the location of substation, and how the site will be selected, and what is the rating of distribution substation, and design consideration of primary and secondary systems, and voltage drop power loss calculations, and application of capacity in distribution systems. So this can be studied in detail in your last semester, that is electrical distribution system. And this so that the high voltage transmission system links the generators to substation which supply power to the user through the distribution system. So that is PS1 is generation, PS2 transmission, and final distribution, that is electrical distribution system. So this is all called power system. So what is power system operation and control? So our subject is power system operation and control. Then what is power system operation and control? So you are generating, you are transmission, you are distributing. But what is the need of power system operation? and why power system control is required. We can discuss this operation and control in this subject. So what is the need of power system operation? The operation of power system needs proper coordination between the devices such that the fundamental variables of the system remain within desired limits. The operation of power system needs proper coordination between the devices such that the fundamental variables of the system remain within desired limits. What are the fundamental variables? That is system variables. There are three types of system variables, that is control variables, that is PG and QG, that is nothing but real power and reactive power generation. Second one is disturbance variables, that is PD and QD, that is real power demand and reactive power demand. And final one is state variables, that is V and delta. These three comes under the system variables. So first, control variable. What is control variable? The real and reactive power generations are called controllable variables since they are used to control the state of the system. And second one is disturbance variables, that is PDQD. The real and reactive power demands are called demand variables since they are beyond the system control and are hence considered as uncontrolled or disturbance variables. Now state variables. The bus voltage magnitude V and its phase angle delta display the state of the system. These are dependent variables that are being controlled by the control variables. Okay, this is the system. These are the system variables. So these are all should be with tethered limits. So next, why power system control is required? A power generating system has the responsibility to ensure that adequate power is delivered to the load. That is, required power is delivered to the load both reliably and economically. That is, the operation and control both are in feasible by using economically. That is, for the investment it should be in our hands. That is, to minimize or optimize the cost, and the operation should be smooth. Hence a power system control is required to maintain a continuous balance between power generation and load demand.